Okay, so good evening, everyone. Welcome to the second part of the define phase. Let me just recap the things we've covered in the previous session. So let me just admit another person coming in. Okay, another person coming in. Oops, admit. Okay. Okay. So we said that if you are there are three ways that you can encounter the type of challenges that you might want to encounter. There's the just do it, where you know what the problem is already. So no need to go through the entire DMAIC methodology. You just apply what you want. Another challenge that you might encounter is a lean type of project where it's more about cycle time. So you use lean tools. Or it might be that you don't know what's causing the issue, and this can be a full-blown Six Sigma project. So if you are going to do a full-blown Six Sigma project, chances are in Define, you will be required to map your process. So it's really important to know that you are able to map your process so that everyone will have a common understanding. And the picture here is just an analogy that sometimes if you don't paint the entire picture, people might have different interpretations. And mapping the process is quite useful, especially in a service industry. You might recall that Lean Six Sigma started first in the manufacturing setup, but then the service industry realized that the tools of Lean Six Sigma can be applied in the service industry as well. If you go to a manufacturing plant, like the picture shown on the left side is a typical manufacturing plant in a chewing gum company, you are able to visualize actually the transformation that's happening. You can see with your own eyes how a chewing gum is produced. So even without a process map, you're able to visualize the transformation. But in a service industry, that is not the case. So I used to work in a business process outsourcing company for a bank, and we were doing financial reports. And when you go to the operations or what we call the shop floor, you will just be seeing that's typical picture that's shown on the right. You just see people sitting in front of their computers. So you don't see actually the transformation that's happening. So in this case, you don't get to see how financial reports are actually being done from journal data. And this is where a process map would really be useful because you are able to show how the transformation is happening. So again, if you are doing a full-blown Six Sigma project for your company, it's almost always required that you map the process in the define phase. So as I've said in the last session, there's several ways that you can map your process. The first one is the SIPOC. The second one is the flowchart. The third one is the cross-functional chart, and the fourth one is the value stream map. This list doesn't mean to be exhaustive, but these are the most common types of mapping exercises. And the way you would map a process, there are actually different levels. So it depends, again, on the focus of your project. So it varies from one project to another. So you can have a level 1 type of a process map, which is from the highest level, which basically you just have block diagrams to illustrate the major step of process. So an example here would be a process in terms of hiring a new candidate. So it goes here, the main task of job posting, candidate selection, job offer, and onboarding. Or you can zoom in further. You can have a level 2 kind of process map, which has more detail. Could be like a more detailed version of hiring, like the submission of requirements, the assignment of body, activation of badge, you activate the email, assignment of workstation, and orientation. And the most detailed level is considered level 3. It's level 3 when you have already like decision steps, if you have information such as waiting time, storage, inspections, and other rework. So your process map can have different levels. And you might be wondering, what level are you going to use for your project? So again, it depends. It depends on the situation. If you are looking at it from from a high level perspective, chances are the required process map would probably be level 1. But if you are looking for a specific process in your own department or your own function, it's probably going to be level 3. In my experience, for people running a yellow belt Lean Six Sigma project, it's almost always they use a level 3 process map. So it's that level of details. Okay, so let's go through some of the commonly used types of process mapping. So the first one is quite simple. It's called SIPOC. It stands for Supplier, Input, Process, Output, Customer. And this is normally used just to align yourself to the customer. As I've said in the earlier part of the discussion, I think it was last week, there are 2 types of customers. You will have the internal customer and you can have the external customer. Again, it depends on the specific process that you would want to improve. So the one shown on the screen is an example SIPOC of a process of producing coffee. So in this case, let's say that the customer is you. The expected output that you would want from the process is hot coffee. And what's the process of building the coffee? It could be grinding the beans, putting the ground beans in the coffee filter, and placing the filter in brewer and brewing the coffee. So then you would ask yourself, what are the inputs for those process? What are the materials needed? So it can be coffee beans and water. And once you have the inputs, you ask yourself, who supplies these inputs? Again, this is just a very simple tool, SIPOC, but it's quite useful if you want to align your process to your customer. Because once you align your process to your customer, you know what the required output of the customer is, and you are able to identify ways to satisfy your customer. So we tackled SIPOC. This one is an example of a flowchart. And I can probably say that most of you have probably encountered already a flowchart. It shows to you the flow of the process. There's the start button. And what is shown here actually is a sample flowchart of a person who does vaccination. Okay, I just wrote down here the process when I had my vaccination before. The process that we had in my province was that if I would go for a vaccination, I would show my ID to a station, and there's a frontliner there who will indicate my classification level. Sometimes they segregate the senior citizens to people at risk or regular people. Then they would give a form, and then there's someone who does the after you fill out the form, there's a frontliner who takes your blood pressure. If it's not normal, you have to reschedule your vaccination. If it's normal, then there's a doctor who reviews your medical history and will determine whether you are fit for vaccination. And if yes, then you get vaccinated. So this is just a sample a flowchart, example of a process map. And these are the 5 most important symbols when you do a flowchart. You have a start and an end, which is in the form of an oblong. You have an operation, which is a rectangle, which identifies a specific activity, which changes an input. Okay. Normally, a good practice is you start an operation with a verb. Okay. And then you have an arrow, which indicates the movement from one operation to another. And sometimes you need a circle as a connector because you cannot fit in one single line in an illustration. So you might want to have a connector sometimes. And then the diamond symbol is used for a decision. Because sometimes you need to ask a question whether you need to perform a specific operation, and it depends on the condition. Okay, so that just remember these 5 symbols, and you should be able to do a sample flowchart. Okay, another variation of the flowchart is what we call a cross-functional flowchart. It's just like a flowchart, but the added level of information is you are segregating the task based on the person who is doing the task. So in this case, it is just the same flow chart that was shown earlier on vaccination, but this time it is indicated to show who is doing the action. Okay. So normally this kind of process map, the cross-functional flow chart, or it is also called the deployment chart, is used for a process where there are different handoffs. Okay, so there are more than 2 persons who are involved in the process. So here it would be nice to show it in this form because you get to see how one output is going from one person to another. Okay, so this is a version that you may want to consider in your Six Sigma project, especially if your process involves handoffs. Okay, over here are some of the process examples I have dealt with in my career. I've handled a project on materials requisition, which is about the customer would order something and then the output will be the material that was requested. It could be the maintenance of machines. So we start with a machine that is needed to be repaired, and then the final or the end of the process is a machine that's repaired. Okay, I've been in a manufacturing company dealing with manufacturing of electric meters. I have supported a process on employee recruitment and also a process in financial report preparation. So here are just some of the process examples I have encountered. Okay, another process map is called the value stream map. Normally this is used, okay, if your process is about improving cycle time. Okay, for now I'd probably just give a high-level view for this one, unless later on you would be asking about a project that involves reducing of cycle time. This is where value stream map would be useful. But for now, I'll just give you a high-level overview. The difference of the value stream map versus the, let's say, the flow chart, here there is no decision. It's a single flow process, and it's additional information that's usually given in a value stream map are the waiting time. Okay, and another useful information that's put on the value stream map is the opportunities for improvement. Okay, so as you can see in this diagram, there are what we call bursts here, sunbursts, colored yellow. These are some of the pain points that was encountered in the process. But I think in a flow chart, even in a flow chart, you can also do bursts. So for now, I'm gonna make probably a recommendation for your first yellow belt project. Just do the flow chart first, because normally if you don't have information about waiting time, then value stream map can be a bit complicated. But maybe in the next week or so, I'll probably upload a video on how to do a value stream map. Okay. Here's another example of a value stream map. What I want you to look at is actually the information below each of the process step. So I think this is about the handling of a patient. What is, let me see if I can do some markings. Okay, I have a pen. Okay, what's so special about the value stream map is this information here. Okay. Okay, so this one is about the cycle time. And this one is actually coming from the waiting time. So here, the 2 minutes is the waiting time. So the added complexity of a value stream map versus, let's say, a flowchart is they have information on the waiting time and the cycle time. So how do we interpret a value stream map? So in this case, there's a triage and there's a registration. There's an exam by the RN and another exam. What we mean here by CT is the cycle time. So it means that for the registration, it takes about 3 minutes. But the waiting time, so here, this information is reflected here. Okay, it's taken 3 minutes. But this one is like what you call the waiting time. Okay, it's counted as a waste here. So which means after triage to registration, the waiting time is 4 minutes. Okay. And after registration, it will be the RN exam. They put here that the waiting time is 28 minutes and that the cycle time is 5 minutes. So if you have this kind of information, it can tell you about the total time it will take from the arrival, let's say in this case, the arrival of the patient until its departure. It says here 165 minutes, but the actual value added time is only 46 minutes. When you say value added time, the time where there is actual work that's being done. So this tool is used if you would like to improve the turnaround time of a process. Okay, if there are lots of waiting time. So in my experience, on your first Yellow Belt project, you probably will not be using a value stream map, okay? Unless, of course, and this is the big unless, you have information of your cycle time and of your waiting time, okay? So for now, I will just briefly mention the value stream map. Okay. And in a value stream map, well, a good question is, what if you don't have a waiting time or cycle time? Can you still use a value stream map? The answer is yes, but it's just like a flow chart. Okay, so you can even use a flow chart, and from the flow chart, you identify what are the wastes considered as waste in your process. So, or pain points or opportunities for improvement. There are actually 3 opportunities for improvement in your process. The first one is what we consider muda or waste, okay, anything that doesn't add value. And we will discuss later what are the different types of wastes in a process. Another pain point could be mura, okay, the Japanese term for mura, which is unbalanced load. Okay, so normally this is applicable if there are 2 or more people working in a process and one person is overloaded and the other person is not as loaded. Okay, that is an example of a pain point that is mura. Okay, another pain point in a process could be muri, which means that a person is doing too much already of the load. Okay, so you can reflect these pain points when you do a process map. But our focus will be probably the muda here. There are 8 types of muda or waste, okay, and we will cover that in the next. So these are the 8 types of muda or waste: transportation, inventory, motion, waiting, overproduction, overprocessing, defects, and skills. Okay, and the acronym is actually TIMWOODS, okay, TIMWOODS. And we'll give examples of what we mean as waste. So the first type of waste in a process is transportation. By the way, there was supposed to be a slide here about the definition of waste. I do apologize, it's probably hidden right now. Waste is anything in the lean concept. It's anything that doesn't add value. Okay, there's no transformation that is happening. So we are going to look at the 8 different types of waste in a process. The first one is transportation. Transportation is a movement of work from one place to another. And this is more applicable actually in a manufacturing setup. Okay, when you move, let's say, one part to another, there is a transportation that's involved. It is considered waste because there is no transformation of the product. So I will just skip it for now here, this one, because this is not often encountered in the service industry. Okay, the second type of waste is inventory. Again, this is probably more applicable in the manufacturing setup. Inventory is when you buy a lot of materials and then they're waiting to be processed. So I think the best analogy I can think of is probably at home. If you have a budget and let's say you use like 80% of budget to buy a year's worth of coffee. Okay, so let's say you bought a year's worth of coffee. That is considered waste because although you are going to consume the coffee, that money could have been used somewhere else, buying other products. Okay, so too much inventory is a type of waste in the process. Okay, let's go to motion. I think this one is probably a common type of waste that is encountered in a service industry. So this type of waste is about movement of the body or mind to perform work. It's wasteful because it consumes resource, time, and energy. An example, if you are dragging too many fields information which can be auto-uploaded with a small macro. Okay, so normally this is when you're dealing with an Excel file. Okay, sometimes the process can be too manual, it's taking so long when that can be addressed by a small macro. So that's a type of a waste. Okay, another one that's probably a lot of you can relate, unearthing a document buried in several subdirectories. Okay, sometimes you have, if you look at maybe your filing process in your laptop and you had to click, let's say, 7 subdirectories just to get a document, chances are there is a lot of motion waste in that one. Okay, so normally my rule of thumb, okay, if I ask myself, because right now for the past 5 years my main client is like, I'm sort of a consultant or providing resource to this client. Sometimes my client during a call would ask for a specific file. Okay, and I usually have a 10-second rule. I should be able to locate my file within 10 seconds. Let's say if my customer would ask for a random file, I should know where that file is located and I should be able to access it in 10 seconds. If I can't, then that is a signal to me that I need to improve my filing system because there is motion waste. Okay. Another type of motion waste will be like inputting information manually when in fact you can copy it automatically. So this is quite a struggle for me. In one of my clients, sometimes we would do a meeting and my client would do the editing in his Excel file while I'm just watching. It's a bit painful because sometimes my client would just type manually the information when it could have been faster just copying and pasting it. Okay, so that's an example of a motion type of waste. Chances are this kind of waste is quite readily can be seen in your everyday process. Okay, next type of waste is waiting. Okay, it's any delay in your value stream. Okay, waiting lengthens your overall cycle time. So this is quite common. Some kind of waiting is inevitable. You cannot totally eliminate it, but you might want to ask, in which part of your process can you reduce the waiting time? Okay, so some examples will be succeeding process waiting for inputs to be supplied by other people, or it might be that you're working with a team, and let's say it would require 5 inputs from 5 people, and 4 people have already submitted their inputs, and you're just waiting for 1 input. Okay, so that's an example of a waiting type of waste. Or it could be a waiting for a testing results from an engineering team. Okay, so any form of waiting is considered in the lean concept as waste. Next type of waste is overproduction. It's producing more quantity than what is required by your customer. Okay, so like for example, printing paperwork before it is needed. A good example here is, for example, you might be working on a document and it's still, going to be updated, but you already printed it and you printed a lot only to be updated. So I think that's kind of waste. Okay, anything that's produced beyond what was scheduled. Okay, that's an example of an overproduction. Another type of waste is overprocessing. Okay, too much processing of information. Let's say, I don't know, maybe you are working in a process where you need to submit a document to a client, and you might have more than probably enough approvers or reviewers that can delay the submission. Okay, you might want to check your process if you have unnecessary approvers or reviewers. Okay, a good example probably in finance. Let's say in finance, when you have to request for a product, maybe sometimes the approval would have to go to your senior manager or to the big boss, and that can actually take some time. So you might want to consider, like, for a certain product where the cost is not that big, you might have approval levels that you don't need the senior manager to approve it. Another type of an example of overprocessing waste would be you have a presentation and you do multiple enhancements on it, or you have duplicate processes, or you have excessive information. Yep, someone asked, would red tapes in government agencies fall under overprocessing? Yes, definitely. Thank you, Jonas, for that feedback. In fact, a lot of government processes can be improved, by eliminating the waste. Okay, next one. Defects. Okay, defects is anything that does not meet your customer's specification. It can result to customer dissatisfaction. Okay, it is wasteful because it requires additional investment to contain or correct the defects. So an example will be you give incorrect information to your client, or you used an obsolete document as a reference, or you provide the wrong feedback to your customer, or you uploaded the wrong report to a wrong site. Okay, so these are just some examples of defects. And let's say you work in a catering company. Okay, you provide food to your client. An example of a defect will be your client ordered for fish fillet and you serve beef steak. That's an example of a defect. Okay, providing something which is not aligned to what your customer requested. This is the most common probably waste in a process. So have a look at your process and identify what were the defects in your historical process. And the last type of waste is skills. Okay, it's not using the employee full intellectual contribution. This can be a costly allocation of resources. So some examples, you have senior manager signing cash expense approvals when that can be done by someone more junior, okay? Or you might have a highly paid staff doing routine tasks, okay, that don't require their unique expertise, okay? Or you're not providing the business tools needed to perform and continuously improve each employee's assigned work. Okay, so those are the different types of waste, the TIMWADs: transportation, inventory, motion, waiting, overproduction, overprocessing, defects, and skills. And I'll probably give some examples later on in the Q&A. If you'd like, I think we're done with this topic. So I think that's it for this section. We've covered the different types of waste. So with that, I think I can pause now the what do you call this? The recording.